All right, so we're going to talk about acids and conjugate bases. We're first going to deal with single compounds, and then we'll take a look at a full chemical equation. So here you see some of my light bulb moments. So once again, we're talking about those pictograms that I like to put out there to remind you of things you need to look for. So one of the things we know about acids are items or compounds that donate hydrogen. Okay, so think about acids as donors. Acids are donors. And then it tells you another note. Remember to note the change. So we have delta here representing the word change in charge. So in acid, you're going to think about a change or a decrease in your charge. So to write these, you're going to lose a hydrogen and adjust your charge appropriately. So here we have H2CO3, and then our second question is going to be H3PO4. So let's take a moment and write those two down and give it a try. Remembering that we lose a hydrogen, so we should go down in our number of hydrogens, and we should also adjust our charge appropriately. So go ahead, pause the video at this moment and go ahead and give that a try for your acids, changing to conjugate bases. All right, so let's take a look. If H2CO3 were to donate a hydrogen and become a conjugate base, and I remind people that conjugate means it was not originally this item. Just like in learning a foreign language, we conjugate verbs. So in this sense, we're going to change something that wasn't a base into a base. So to change H2CO3 to a base or a conjugate base, we lose a hydrogen and we decrease our charge. So hydrogen we know would have one electron, so it has actually left as well as that one proton. So now we have HCO3 with a negative charge. Let's take a look now at H3PO4. So if we have an acid that is going to become a conjugate base, we know that acid has donated a hydrogen. So we're now going to have H2PO4 negative because we have lost those hydrogens that allowed that one positive to be in its place. So now we are negative in our charge. So let's take a look at our next one. We're now going to go in the opposite direction. We are going to do a base going to a conjugate acid. So with bases, they accept a hydrogen, and remember to note the change in charge. So for bases, they're going to increase in charge. So they will go up by 1. Okay? So let's take a look. We have SO4 with a negative 2 charge, and we have NH2 with a negative 1 charge. So take a moment to write those down and give them a try. All right. So what is going to happen to my SO4 to negative if it accepts a hydrogen? He is now going to have an additional hydrogen on that compound. And we're still going to have our SO4, but it went up one time in charge. So from -2, it has now gone to just a -1. All right. So now we have NH2 negative. NH2 negative. What has happened to him if he actually accepts a hydrogen atom? All right. So let's look. We still have that same nitrogen in the beginning, but we now have H3 with a neutral charge because we started off negative, and if we add one, just as if a bank account or a particular account is negative by 1, if we add 1 to it, it then takes it to 0. So this NH3 now has a neutral charge. So now that we've done separate compounds, let's look at this in the sense of a chemical equation. So here we have H2SO4 plus H2O yields H3O plus 1 charge plus HSO4 with a -1 charge. This is when I would take the time to utilize 2 different colors of writing implements because we need to decide who is an acid and who is a base. So the first thing I would do for this problem is find out which one of my reactants is paired with which one of my products. And I would place some type of note or color around them. So if I look here at H2SO4 in my reactant side, that doesn't look very much like this compound in my product side, but it does look a lot like this one. So I feel that those two are going to be paired together. So I'm going to draw some type of symbol to remind myself visually that these 2 items are being compared. Then, of course, if those are the 2 being compared there, then these 2, my H2O and my H3O plus, is what is being compared here. So now we need to decide who is an acid and who is a base. And once we determine the acid, we'll know who is going to be a conjugate base on the product side, as well as finding the other component. So if we look here at H2SO4, he changes to HSO4. So did he donate or accept a hydrogen? Did he donate or accept a hydrogen? All right, for those of you that said that he donated, you are absolutely correct. So he would then be considered my acid. So if this is my acid, his component on the product side is going to be my conjugate because it wasn't originally this, but it's now my conjugate base. He has changed. So look at it as acid changed to base. Conjugate just represents change. So that acid has changed to a base. So if we look at H2O, he then becomes H3O plus. Did he accept or donate a hydrogen? For those of you that said he accepted, you are absolutely correct because we increased from 2 hydrogens to 3. Our first compound gave away a hydrogen, so we know that H2O is going to be my base. And on the product side, he has become my conjugate acid because he is a base that changed to an acid. So there are our examples of acids and bases in the sense of a chemical equation. All right. So happy studying once again to you for acids and bases. So just make sure that you're looking for those patterns and remember those light bulb moments.